Hi folks, I'm meteorologist Jay Burschback along with Carl Nelson at the Imagination Station. Today we're dealing with the power of ethanol, a very clean burning fuel, which we're going to demonstrate here over the next minute or so. Go ahead, Carl.
That's why I use that as an additive for gasoline. We've got some ethanol here. It's about 180 proof, 95% alcohol. And you can see it burns with a really clean flame.
Yes.
Right? There's no soot or anything coming off. And we're going to use this idea of ethanol burning and combustion to power a rocket.
Okay.
Now, I do have to point out, this is not an experiment you are going to try at home. We do have a safe version of this using just water. Check out our website. But for you and IJ, we're going to use the ethanol. Why don't you go ahead and get rid of that flaming tray.
Alrighty.
Here's what I'm going to suggest we do. We take some ethanol and we put it inside a 2-liter jug here.
Sure.
We're going to get rid of the excess ethanol. And now inside we have a mixture of of air and ethanol.
Okay.
I'm going to lay this on our table. In fact, let's get rid of all the liquid. We don't want any liquid in there because that's just going to leave a flaming trail on the table. What we really want...
Like Back to the Future?
Like Back to the Future,
yes,
exactly.
Okay.
What we want is just a mixture of air and alcohol. Okay?
It's pretty impressive.
So the combustion happens inside the container, it ejects the gases, and it takes off in, there you go, there's your Back to the Future.
Thank you,
we did get a little bit of flaming alcohol.
No flux capacitor, though.
Not today. No flux capacitor.
Wonderful.
But what would be even better, I think, is if we could somehow take the force of that gas that's coming out the back of the bottle and restrict it, or actually increase the pressure by using a tiny little hole. So I got a tiny little hole here, about a 1/4 inch on the bottle cap, and that should increase the speed of a rocket, in theory. All right, this is my...
Sure, that's why we do experiments.
This is my guess.
All right, I'm going to back up on this one.
Why don't you give me a countdown here and let's see what happens.
Are you ready?
Yep.
3, 2, 1.
Isn't that nice?
I mean, that sounded and looked just like a rocket, like
off.
a firework or something.
Absolutely.
That is amazing.
All because we restricted the gas to a smaller opening. I mean, this is like what you do when you're designing rockets. The nozzle design is very important. Let's try that again.
Is this a different nozzle or same nozzle?
Same size nozzle.
All right, I'm going to back up.
You know, we hit the pillar over there. This time, let's see if we can miss the pillar. Give me a countdown.
3, 2, 1. Bleachers this time.
It just takes off.
Thank goodness we cleared the crowd out.
We did. No crowd today.
Yes.
But again, not an experiment you can do at home. But it's all about combustion happening inside that rocket, something that rocket scientists actually have to worry about.
Sure.
Nozzle design to eject the mass as quickly as possible to increase the velocity of the rocket going forward.
That is amazing. Very clean burning fuel, ethyl alcohol.
Absolutely.
Wonderful. Well, thank you very much, Carl Nelson. For Carl, I'm Jay Burschback, and that was Imagine It.